You've seen it 1,000 times in the movies, right? Starships just zipping between galaxies. But forget galaxies for a second. What about a trip to our actual closest stellar neighbor? I mean, it seems like that should be the first step, the easy one. So let's really dig into that journey.
Seriously, it's right next door, cosmically speaking. It's the closest one there is. So you gotta ask, when can we go? When are we packing our bags and getting to see another sun up close and personal? It sounds like a pretty straightforward question, right? But the answer, well, that's where the whole story is.
So let's get into it. For what, decades now, science fiction has drilled this idea into our heads of starships just hopping between solar systems like it's no big deal. And you can see why we dream about it. We've got the perfect first stop practically in our backyard.
And that perfect first stop is Proxima Centauri. Think of it as our sun's closest buddy in the whole universe. And here's the kicker. It has a planet, Proxima b, and it's orbiting right in the habitable zone. You know, that sweet spot where liquid water could potentially exist. A perfect destination. This is where the dream of interstellar travel really begins. It feels so close, so achievable.
Okay, but this is the exact point where that beautiful sci-fi dream slams headfirst into a wall of brutal cosmic reality. And that reality check starts with one simple, absolutely crushing concept: distance. This is the gap we have to cross, 4.246 light years.
On its own, that doesn't sound like a huge number, does it? Just over 4 of something. But it's that something, the light year, that's the entire problem.
So, what is a light year? Well, it's the distance that light, literally the fastest thing in the universe, travels in one single year. And that distance is roughly 6 trillion miles. Trillion! So multiply that by 4.25. You're looking at a journey of over 25 trillion miles. Honestly, our brains just aren't wired to even imagine a distance like that.
But here's a great way to wrap your head around it. Let's say the sun is a grapefruit sitting in New York City. On that scale, our entire planet, Earth, would be a single grain of sand about 50 feet away. Okay, still manageable. But Proxima Centauri, the very next grapefruit, that would be all the way in Chicago. That's the scale we're talking about for our next door neighbor.
Okay, so what does that grapefruit in Chicago distance mean for travel time? Well, if we took our fastest spacecraft ever, the Parker Solar Probe, and aimed it at Proxima Centauri, it would take over 70,000 years to get there. Just let that sink in. That's not a person's lifetime, that's longer than all of recorded human history. It's practically geological time.
So, 70,000 years is, a bit of a deal breaker. The obvious solution then is just go faster. Simple, right? Well, not so much. This brings us to the next massive problem, the universe's ultimate speed limit, and the fact that we are nowhere near it.
Just look at the numbers. Our absolute champion, the Parker Solar Probe, maxes out at about 0.06% of the speed of light. That's it. But for what you might call a reasonable trip to Proxima Centauri, say something that takes less than a human lifetime, you'd need to be moving at over 10% of light speed.
And this isn't just a matter of building a slightly bigger engine. We're talking about a completely different league. The amount of energy needed to push even a tiny probe to 10% of light speed is absolutely mind-boggling, way beyond anything we can dream of producing right now. We aren't just a little too slow. We are orders and orders of magnitude too slow.
But hey, let's just imagine for a second. Let's say we wave a magic wand and solve the distance and speed problems. We've got a ship that can get there in, say, 50 years. Awesome! Except, now you face the third giant hurdle, just surviving the journey itself. The void between stars is not a friendly place.
For starters, as soon as you leave the protective magnetic bubble of our solar system, you're getting blasted by relentless, high-energy cosmic radiation. It just tears through DNA and fries electronics. Then there's the fact that space isn't actually empty. It's full of tiny dust particles, and when you're moving at 10% of the speed of light, hitting a single grain of sand is like setting off a bomb. It would vaporize the ship. And let's not forget the human element. Even if you solve all that, keeping a crew sane and a complex machine running flawlessly for decades with zero chance of a rescue, that's an unbelievable challenge all on its own.
Okay, I know. That all sounds pretty depressing, right? The distance is insane, we're way too slow, and the trip itself is a death trap. It really does sound like an impossible dream. But what if we're just thinking about the dream the wrong way?
So, is that it?
Is the dream of visiting the stars just dead? Should we just give up and accept that there'll only ever be pretty lights in the night sky? Is that whole grand adventure over before it even got started?
No, not at all. We just have to change how we think about it. Maybe that vastness isn't a barrier. Maybe it's a giant canvas, just daring us to find smarter ways to see what's on the other side. Because, physically going somewhere isn't the only way to explore.
And that's really the key takeaway for us right now. Our generation's starships, they aren't built out of rocket fuel and metal. They're built out of giant mirrors and incredibly sensitive sensors. We are already exploring Proxima Centauri and thousands of other worlds right this very second. We're just not doing it with our bodies. We're doing it with our instruments.
And honestly, we are living in a golden age of this kind of exploration. You've got the James Webb Space Telescope, which is literally sniffing the atmospheres of planets light years away. We have massive new telescopes being built on Earth that will be powerful enough to take fuzzy pictures of these worlds. Our power to visit these places with light is getting better at an exponential rate.
So look, we may never actually stand on a planet around Proxima Centauri, maybe not in our lifetimes, but we are getting closer to truly knowing that world every single day. The real journey isn't about moving our bodies across space, it's about expanding our understanding. And that leaves us with a far more interesting question, one we can actually answer. What incredible wonders are we going to find next? Not by going there, but by getting better and better at the art of looking.